This next lesson has to do with graphing by t-chart and looking at x and y intercepts of lines. So the very first thing I'm going to mention is that if I just kind of throw down a grid and I put two random points anywhere, I can connect those 2 points and form the unique equation of a line. I'm not going to be able to draw this very well, but I'll just try to kind of sketch through. That's the only line that could ever go through those 2 points, and we call that a unique line. It's unique because if I put down any 2 points, there's only one way to connect them to connect a line through those 2 points. So when we kind of say there is one way, or we'll say there is one unique way to connect two dots, or to connect two ordered pairs, this is another very, very important concept linked to the idea that 2 points determine a line. 2 points are all you need to make a line, and a line contains infinitely many points. So there's a point here, 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 and here. Now right here, this particular point is called the x-intercept. And if I zoom in on it, it is the x-intercept because it is the one crossing the x-axis. And this point right here is called the y-intercept. And it is called the Y-intercept because it is the point that crosses the y-axis. Not every point has both an x, or sorry, not every line has both an x and y intercept. Most of them do, but there's a subset of lines that don't. Here is a type of line that does not have a y-intercept, but it does have an x-intercept. This right here is a vertical line. It has an x-intercept right here, but it has no y-intercept because it runs parallel to the y-axis, which is right here, and it will never cross it. Likewise, another type of line, a horizontal line, is going to be very similar from the other perspective. If I graph a horizontal line, let me just put one line like that. This is a horizontal line, and it has a y-intercept here, but it has no x-intercept. But the majority of lines that we're going to deal with have both x and y-intercepts. So if I look at one right here and I put a point at 2, 2, and then I put a point at -1, -1, let me write that right here, and then if I connect those 2 points with a line, and I'm looking ahead to see where I need to put this so it actually completely goes through both those points, I can see I have both an x and a y-intercept. Now this is a special case because the x-intercept is the same as the y-intercept. That's the ordered pair 0, 0. But here's another case where maybe I draw a line. I'm just going to do a random one like this. And we don't have to look at where those are, but I can see I have both a y-intercept and an x-intercept. Now, these lines can be represented by equations, and they're represented by what we call linear equations. And linear equations are equations with x and y. So we have x's and they have y's, both to the first power. So I'm going to show you some examples of linear equations. Here's kind of a classic one, y equals 2x plus 1. It's very simple. It's set equal to y, and I can see that I have a first power on the y and the x. It's linear. There's nothing being squared. Here's an example of a nonlinear. 3xy is equal to 4. What makes this nonlinear is that even though my x and y are to the first power, they're being multiplied by each other, which kind of sort of makes it like it's to the second power, which is not good for linear. That's not nonlinear. So let's do another example. 3x plus 2y is equal to 5. That is linear. You have an x to the first power and a y to the first power. However, if I have 7 over x plus 5 over y is equal to 2. That is nonlinear, because if I tried to multiply both sides by an xy, what I would get would be this form, 7x plus 5y is equal to 2xy, and I run into that same problem as we had before, where it's nonlinear. Here's a linear equation. This is not simplified, but it is definitely linear. I could take it and work it around and make it an x to the first and a y to the first. Oops. But this is a nonlinear. If I have 2x plus 5y squared equals 4. So today we're just going to work with entirely linear equations. In fact, we're going to work with all linear equations for the next several weeks. So you're not going to have to worry about nonlinears. Just to identify when we have a linear equation. So here's an example of one that we're actually going to graph. We're going to do negative 2x plus 5 is equal to y. Now, this kind of graph is just a little bit different. And what I'm going to do with this is just kind of look at it and see, first of all, it is linear. I got a first power and first power here. But what I want to do is I want to find the x-intercept and the y-intercept. Those are two separate points. To find an x-intercept, you let y equals 0 and solve for x. So to do that, I'm going to take this equation, I'm going to replace or substitute 0 for y. Then I'm going to solve for x. So what I get is subtracting 5 gives me negative 2x equals negative 5. Divide by negative 2 and I get x is equal to 5 over 2. So therefore, my x-intercept is the ordered pair 5 over 2, 0. Now, how do I know that? Well, I just substituted 0 in for y, and I got 5/2 for x. Now, I'm going to do the same thing for the y-intercept. This is the x-intercept. Let's do the y-intercept. But to find a y-intercept, you let x equals 0 and solve for y. It's the reverse process, and this is very, very important to keep straight with what you're doing when you get both an x and a y-intercept. So I have a y-intercept. I know that it's going to have a y-intercept, but I'm actually going to take the original equation, which is way up here, and I'm going to plug in 0 for x. So I go negative 2 times 0 plus 5 is equal to y. Negative 2 times 0 is 0, and I get 5 is equal to y. Okay, so what that means is that my y-intercept is 0, 5. It's the ordered pair 0, 5. Now I could take both of those 2 points and put it on a graph. I want to do that. I'm going to put 0, 5. That means right or left 0 and up 5. And then I'm going to put the other one, the x-intercept. 5/2 0 is the same as 2.5 0 or 2.5 0. So that's going to be right here. And then with the straight edge, I could actually cross those points and get a line. That's what you're going to be doing for part of today. You're going to be graphing with x and y intercepts. So let's do one more example. Let's go 7x minus 2y is equal to 14. So to find an x-intercept, I let y be 0. So I'm going to go 7x minus 2 times 0 is equal to 14. Or 7x is equal to 14, or x is equal to 2. That's the ordered pair to 0, and this is the proper way to state a y-intercept as an ordered pair. An x-intercept. Here's a y-intercept. I'm going to actually let x be 0. So to find a y-intercept, I let x be 0. So 7 times 0 minus 2y is equal to 14, or negative 2y is equal to 14, or y is negative 7. So my ordered pair is 0, negative 7. Then I'm going to finally graph this on a grid. 0, negative 7 is, let's see, right or left 0 and down 7, so it'd be right here. if I kept that going down just a little bit more. There we go. And then 2, 0 is right 2 and up 0. So I get this, and just kind of a little sketch. There's my line. So easy enough. We just find 2 points, put them on the grid, and graph the line. So that is graphing by x and y intercepts. There's a second way to graph that we're going to do today, and this is graphing by t-chart. And to graph by t-chart, you first want to set the equation equal to y. We practiced that in the last 2 problems of the homework from the previous lesson. Set the equation equal to y. So what I'm gonna kind of do with that is let's do an example over here on the right. Let's take 3x minus y is equal to 6. So I'm going to set the equation equal to y. I'm going to get the y by itself. So basically what I'm going to do is I'm going to add y to both sides, and I get 3x is equal to 6 plus y. Then I'm going to subtract 6, and I get 3x minus 6 equals y. So I've got the equation equal to y. Step 2 is the t-chart. So what I'm going to do is I'm going to make a t-chart, and on the left side I have x, and on the right side I have y equals 3x minus 6. And I'm just going to start plugging in some numbers. I only need a few of them, but I want to do a few. So let's try 0. I plug in 0. 3 times 0 minus 6 is negative 6. Let's plug in 1. 1 times 3 minus 6 is negative 3. Let's plug in 2. I get 0. Plug in 3. 3 times 3 minus 6 is 3. And that's plenty. That's 4 points. So I'm going to put these 4 points down on a graph. 0, negative 6. 0, negative 6. Then I'm going to do 1, negative 3. 2, 0. 3, 3. And you can kind of see a pattern going here about where these points go. If you predict that the next point would be here, if I plug in 4, 4 times 3 minus 6 is 6, and yeah, that is a point. So we're going to put as many points as we can. I could even put down negative 1 and negative 9. I know that if I plug negative 1 in, I get negative 9, and that's right here. I don't want to overdo it, but I do want to make this a good looking graph, so take those, connect all the points, put arrows on the end, and then we got the equation of a line. So that's graphing by t-chart. I'm going to make that example number 3. Let's make my marker thicker. Okay, let's go to 4. Example 4, let's do y equals negative 5. So this is a little tricky to do by t-chart because there is no x. So how do we get by that? Well, I'm still going to put an x on the left and a y of negative 5. I'm just going to put some ordered pairs down. When I plug in 0 for x, y is negative 5. When I plug in 1 for x, y is still negative 5. When I plug in 2 for x, y is negative 5. When I plug in 3 for x, y is negative 5. Just put a few ordered pairs down, and as I build this graph, I know that when x is 0, y is negative 5. When x is 1, y is negative 5. When x is 2, when x is 3, basically if I connect all those points, I'm going to get something that looks like this. It's a horizontal line, and it's basically at y is negative 5. So that's what that looks like. Likewise, another one I can do is x equals 3. If I just do x is equal to 3 and I build a t-chart, basically this is the reverse of what we just did. So I kind of have x, which has to be 3, and I'm just going to put y, which is not ruled at all. There's nothing listed. So no matter what, x is going to be 3. But I can make y anything. 1, 2, negative 1, 0, 4, it doesn't matter. And as I graph that and just put these ordered pairs down, I know that when x is 3, y is 1, y could be 2, y could be 0, y could be -1, y could be 4. You see what's happening here. They're all vertically aligned, and this is a vertical line. When I connect it, I just connect it as a vertical line. Let's do one more example of a t-chart. And t-charts can be used for a lot of things. Let's do 1/5 x plus 1/10 y is equal to 1. Well, remember, by t-chart I want to set this equal to y, so I'm going to take this equation and multiply both sides by an LCD of 10 so I can get this in a better form. That gives me 2x plus y is equal to 10. Then I'm going to subtract 2x from both sides, and I get y is equal to -2x plus 10. That's a lot better form. Oops. And then I go to t-chart, x, y equals -2x plus 10, and I just plug in some numbers. Let's plug in 0, I get 10. Plug in 1, I get 8. 2, I get 6. 3, I get 4. You can see a pattern going on here. 4, I get 2. And 5, I get 0. That's plenty. You don't necessarily need to graph all of those, but if you can, you could. Let's see, 0, 10. I think I'm barely going to stretch the limits of my graph up there. 1, 8. 2, 6. 3, 4. 4, 2. 5, 0. That's plenty of points to graph. And I've hit both intercepts, which is good. I'm just going to connect the dots as best I can. So that's it.